Everybody, welcome back to another fun and exciting Algebra 2 class. Today we're going to be finishing up lesson 7.5, finishing up talking about exponential and logarithmic equations and how do we solve those. We already talked kind of the first part of the lesson, kind of the basics of how to set these things up. And in this section, what we're going to be talking about is how to solve them a little bit different way, because sometimes it doesn't work the ways that we learned in the first part. Sometimes we have to use what's called the inverse property of the equation. In other words, with a logarithmic equation, we have to change it over to an exponential, and with an exponential, we have to change it over to a logarithmic. That's what inverse means here. If you look on page 355, it talks about the inverse properties and equations, and it says sometimes you can't write an equation in the exponential form. And so when that happens, we have to use the inverse property of the function to get the equation into a format that we can actually solve. And the way that you do that is by using composition of functions. I'm not going to make you go back, and we did learn composition of functions a few lessons ago, a few chapters ago. I'm not going to make you go back and figure this all out, but you can see how they've done it. What is the derivation of that? How do they change that over? And again, that's on page 355. Then you come up to table C. What is table C? Table C is kind of the where we're going in this second half of this lesson. So it says, table C says the inverse properties of exponential and logarithmic functions. How do we do this, in other words? All right, so I've got some things written down here on the screen. If the base of the log equals the base of the argument, then the result is the exponent. What does that mean? All right, well, let's look at it. So if I say that the log of a is a to the x, notice here we have something. The base and the argument are the same. Look, base and the argument base, those are the same. They're both equal to a in this case. So when that's true, so this is the base and this is the argument base, and those are the same. When that's true, the result is the exponent. Okay, in other words, that's going to equal x. Why x? Because x is the exponent. There's a lot of and again, you can go back up right above table C. They show you how they do it. There's a lot of math involved in getting that to be equal, but at this point, we just have to take it as a fact. Okay, they're giving us this property and they're saying, okay, here's how we did it, but here's the fact that you're going to be using. So we have to use this as a fact. So when we do this, let's plug in some numbers here. Let's say instead of a, we can use the number, we'll use the base 5. So log of 5 to the x, that equals x. So notice when this and this are the same, it's going to yield just x, just the exponent. That exponent becomes the equals on the other side. Okay, and again, you don't have to understand necessarily how all that works right now. You can look through it, great, but you just have to take it as a fact. Number 2, the second thing here is if the base of the exponential expression equals the base of the log, the result is the argument. What does that mean? Well, if the base of the exponential expression, so if we have a to the log a of x, and we haven't really seen that yet, but now we have a log up in the exponent. That's what it's talking about here, and that's going to equal the argument of the log expression, so that's going to equal x. So what has to be the same? This base has to be the same as the log base, and if that's true, then you have that it equals the exponent, which is, in this case, or equals the argument, excuse me, which in this case is x. All right, so look through those. Again, that's on page 355. All right, and there's one more thing that I want you to know from this. and it's the word called exponentiation. What is exponentiation? It's the process of rewriting each side of the equation as an exponent. If you notice, I used that in the last lesson. You heard me say it, but I never explained what it meant to exponentiate something. What it means to exponentiate is it means to write both sides in an exponential form, in an exponential equation. So in other words, taking away the log out of it, or the natural log, whichever it is, and writing it all in exponential form is called exponentiation. And that's important. You'll hear me say that every once in a while. Let's jump down here and let's try one of these. Let's use those principles that we just learned. We have on the screen the ln, or the natural log of x, equals 4. The ln of x equals 4. So what do we need to do? We need to round to 3 decimal places, the book says. So our answer is not going to be an exact answer. It's going to be an approximate answer. So that means we're going to have to use our calculators here as well. Let's go ahead and figure out what to do. Okay, so the natural log of x equals 4. So looking back up at these, which one do you think that we should use here? I'll let you take just a second to look at it. Well, the first thing that we need to do on this is to get natural log on both sides. Okay, because right now we're dealing with natural log on one side and then just a number on the other side. In other words, we have to get it to be kind of equal on both sides. And the way that we can do that is by multiplying by the natural log. What is the natural log? Well, it's e. So if we multiply both sides by e, again, we're not changing anything, but we're putting the natural log now, we're putting it into the same format on both sides. So how do we do that? Well, basically we do exactly what I did there. We make these the exponents. Okay. All right. Now what? Well, this is kind of cool the way this works. Look what happens here. This cancels. ln, because it's the inverse of each other. Those inverses cancel each other out, or they cancel out to a 1. And so you end up with x equals e to the 4th. And then you just solve it. You just solve e to the 4th. Go to your calculator, and we're just going to put in e to the 4th. So click our e, and then our, with a little exponent, to the 4th equals, and we get 54.598. So 54.598 is the answer. The book, at least the book that I have, the copy that I have, actually has that rounded off wrong. It should be 54, so it should be x bacon approximately equals 54.598. The book that I'm looking at says 0.599, but if you look at our calculator, the number after the 8 is a 1, so that would leave that as an 8. So there you go. That's how you do that one. With the natural log, you just get the log to cancel. You do the same thing if it was log. If it was log base 10, if it's log base 3. If they're the same, you can get the logs to cancel out. That's what you're trying to do. You're trying to cancel the natural log. In other words, you're trying to get x by itself. Okay, and how do you do that? You multiply everything by e. All right, let's try this one. All right, what do we do here? What's going on here? Well, kind of the same concept is going on here. So let's just try the same thing that we tried before. Now it's e on this side. So what do we have to multiply by to get rid of the e? We're trying to get that by itself. The ln, the natural log. Okay, so if we multiply both sides by the natural log, that's going to cancel this, and we're going to get x plus 3 equals the ln of 9. Okay. We can't just say, well, I'm just going to find the ln of 9. No, we still have this plus 3 over here. So we need to subtract 3 from both sides, and we get x equals the ln of 9 minus 3. And you might want to write this in parentheses like that, but it's order of operation. It's an exponential thing right here, so you would solve that first anyways, but I just put parentheses on it because it might be a little bit easier for you to remember. So we're going to go back to the calculator. Let me bring it over here, and we're going to do the natural log of 9. So on mine, I have to do 9, and then the natural log, the ln, and I would type and hit equals. And that gives me that 2.19, and then I just minus 3 equals. And I would get negative 0.803 would be my answer. And now that wouldn't be my answer. That would be x is approximately equal to that. Okay, because don't forget, that's a rounded off number. Okay. All right, well, that's all I have for you for this second half of the lesson, and I know it's a lot shorter than the first half, but I wanted to do it in 2 parts because I didn't want to cram that into the end of the other one. One of the biggest things to remember on this is what you're trying to do is, if it's natural log or if it's log, whatever it is, you're trying to get that to cancel out. So you multiply both sides by whatever it is, log 3, natural log, log 10, whatever you're multiplying by to begin with, and you get the exponent by itself equals something over here, and then you can keep going with it. But that's really the trick. The trick is canceling out something from the left side to get x by itself, because that's our goal in any equation, is to get x by itself. Okay, so if you can kind of remember that, keep that in mind. I'm always trying to get x by itself. So how do you get x by itself? Well, all the way through algebra, what have we done? We've always done the opposite. What's the opposite of e? ln. What's the opposite of log? Okay, so you keep doing the opposite of those things, dividing by those things. If it's multiplied by log, you divide by log. If it's if it's multiplied by e, then you divide by ln. Just things like that. Do the opposite to get it by itself, and then you can solve the rest of the equation. All right, well, if you missed anything there, make sure you go back and scroll it back so you can learn it. And I hope you did learn something there. And if you have any questions, you can always drop them there in the comments, and I'll try to get to those questions when I can. All right, we'll see you later. Have a good one. Bye-bye.